Good day, everyone. Welcome to Calcumind. Today, we are going to be looking at past questions under statistics, in particular, probability. So, for our first question, we have that Belema plays for RSU football team. He makes a goal 65% of the shoots. Belema is going to attempt 2 goals in a row in the next game. If A equals the event that he is successful on his first attempt, the probability of A equals 0.65. So for the first parameter that we are given under question 1, we have that the probability of A equals 0.65. B equals the event that he is successful on the second attempt. The probability of B equals 0.65. So for our second parameter, we have that the probability of B equals 0.65. Belema tends to shoot in streaks. The probability that he makes the second goal, given that he made the first goal, is 90. Now, this is conditional probability. So what this implies is that the probability of B given A is equal to 90. So for our first question, we are asked to I, find the probability that he makes both goals. So I, the probability that he makes both goals. Now the probability that he makes both goals is the probability of A intersection B. So that will be probability of A intersection B. This is what we are looking for. Now if you recall the conditional probability formula, we have that the probability of B given that A has occurred is equal to the probability of A intersection B, all divided by the probability of B. Now we just have to substitute the values that have already been given to us. So we have that the probability of B given that A has occurred is equal to 90. The probability of A intersection B, we are looking for this, divided by the probability of B, which is 0.65. So we cross multiply, we have that the probability of A intersection B equals 0.65 multiplied by 90. So we have that the probability of A intersection B equals 58.5%. So for our second question, we are told to find the probability that he makes either the first or the second goal. So we are told to find the probability that he makes either the first or the second goal. Now remember that whenever the term either comes in, we are looking at union of events. So we're looking at the union of the event A and the event B. So what we are told to find for the second question is the probability of A union B. So recall that the formula for the probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersection B. So we have that this is equal to 0.65 plus 0.65 minus 0.585, which is equal to 0.715. So the probability that he makes either the first or the second goal, which is the probability of the union between events A and B, is equal to 0.715. Now the third question,
they say find the probability that A and B are independent and explain.
Find the probability that A and B are independent and explain. So we are asked whether the two events are independent. Now, independent events are events that can occur simultaneously without affecting each other. So for example, if you were to toss a coin and roll a die at the same time, you can achieve both without either of the events affecting the other. Now, mathematically, for an independent event, we have that the probability of one event occurring, for example, probability of B, given that the second one has occurred, probability of A, is equal to the probability of the first event alone. So mathematically, we have that the probability of two events being independent is that the probability of one occurring, given that the second has occurred, is equal to the probability of only the first one. Now, from our earlier question, we are given the probability of the second event occurring, given that the first event has occurred, and it is not equal to the probability of the first event occurring. Therefore, events A and B are not independent. Now, for our fourth question,
So find the probability that A and B are mutually exclusive. Explain.
we are told to find the probability that A and B are mutually exclusive. Now, while independent events mean that the two events can occur simultaneously without one affecting the other, mutually exclusive events implies that one event cannot take place while the other is occurring. For example, if you were to roll a fair die, you wouldn't be able to roll both a 3 and a 5 at the same time. So it's either you roll the die and you get a 3, or you roll the die and you get a 5. So we are asked to find the probability that the events A and B are mutually exclusive. Now, mathematically, the probability of mutually exclusive events is that the probability of one event, let's say event A, and the intersection with another event, let's say event B, equals 0 for mutually exclusive events. But from what we've solved so far, we have that the probability of A intersection B is equal to 0.525, which is not equal to 0. Therefore, events A and B are not mutually exclusive. Thank you very much for watching. Please, if you've enjoyed the video, do well to like, share, and subscribe.